Hello again, ladies and gentlemen. This is Mr. Arias, and my channel is Math to the Point. In today's class, we're going to basically find out how to come up with the equation of a quadratic function in vertex form if all we know is a quick description of what's happening to what we call the mother function, parent function, or father function, which in this case is the function f of x is equal to x to the power of 2. That being said, let's get into the problem. And the problem says the following. Our job in today's class is to find out the function g of x, which is a function that shows the following changes on the mother function. G of x is a translation of 7 units to the right and 4 units down. Now, just to clarify, when we're talking about translation, that basically means a shift or a movement across either the x-axis or the y-axis. So again, just to review, this is something that I mentioned last time in my previous video. Anytime we're talking about a translation, what that means is that this will be a shift or a movement. Okay? And then the other thing I want to point out is how we are still taking into account the parent function, which is f of x is equal to x to the power of 2. So this is the parent function. And again, we call it the parent function because this function is basically the starting point for any given quadratic function in existence. So this one will be here, my parent function. Okay, perfect. The other piece of information that I want to get your attention to is that they want this to be in vertex form. So they're telling us all these changes that are happening, all these translations or shifts or movements, and they tell us that the final answer should be in terms of the following equation, which is the equation a times x minus h to the power of 2 plus k. And technically, just to get to the bottom of this, all we have to find out in this problem is the value of a, the value of h, and the value of k, and those happen to be integers on this problem. But just so you know, those do not have to be integers. In any other problems, they can actually be decimals, they can be fractions, irrational numbers, or anything like that. Okay? Now, let's get into this. Just to recap again, I want to remind you, ladies and gentlemen, that this is always true. Since we have to find the values of a, h, and k, you have to keep in mind that each one of these values produces a change on the mother function. The value of h specifically determines if the mother function is being translated or shifted horizontally across the horizontal or x-axis. The value of k tells us that the mother function is being shifted or translated vertically across the y-axis. And then lastly, the value of a is telling me a few things. It's going to tell me if the function is opening up, if it's opening down, if it's being stretched, or if it's being compressed. So this is kind of like a visual representation of a stretch, and this is a visual representation of a compression. Okay, so technically speaking, we're going to determine the value of a in just a second, the value of k, and then the value of h. Now, if the value of h is positive, that means that the mother function is being translated to the right-hand side on the x-axis. If it's negative, that means we're basically going to the left. Same for k. If k is positive, that means that the mother function is being shifted up. If it's negative, then we have it going down. And then, I don't know if you noticed, but on this problem, we're not going to have any stretches or compressions. We're going to have two choices. Either a is going to be positive 1 or negative 1. If it's positive 1, that means that the function will be opening up like the mother function. And if it's a negative 1, it's going to be opening down. Now, this is the situation. And based on these values, we have to basically determine what are the values of h, k, and a. Now, that being said, all I have to do at this point is come back to the main problem. If you notice, the problem says that this function g of x reflects a translation or a shift or a movement of 7 units to the right, which basically means that the value of h is making the parent function f of x is equal to x to the power of 2 move 7 units to the right hand side on the coordinate plane. That makes my value of h be a positive 7. Okay, so the value of h is equal to 7. Now, for k, we go back to the problem and we notice that it says that this function g of x is also reflecting this change of 4 units down. So what's happening is this: the mother function, which was originally centered at the origin on the coordinate plane, is being shifted to the right hand side 7 units and then down 4 units. So technically speaking, those are the values of h and k. Now, because the function is being shifted down 4 units, and we said that anytime you're going down, that represents a negative value of k, then that'll be your integer, which is -4. Okay, we just found the values of h and k. The last thing we have to find is the value of a, which, like I said, would be either a positive one or a negative one. And that's because the problem is not really saying anything about the mother function being compressed or stretched. Now, in this case, if you notice, the context of the problem never says anything about the function opening up or opening down, being stretched or compressed. So when that happens, you can automatically assume that this function is behaving specifically in the same way as the mother function in terms of its shape. So what that means is that the value that we'll have to assign to this equation of this function, vertex form, will be +1. And like I said, that's because we are assuming that the shape of the mother function is being respected. Okay, and then just to recap, the value of a that this function has, f of x, is equal to +1. There's a +1 right here that is multiplying by x to the power of 2. So that's going to be the same one we're going to choose for this equation. Okay, so now we have the values of h, k, and then a. So we're good to now come up with the final equation. Okay, so all we have to do at this point is to place the values of h, k, and a into this equation, and we'll be able to find out the final answer. Okay, so let's begin. I'm going to copy down my function g of x is equal to a. We said that a is equal to +1. So I'm going to replace that to +1. And then we're going to open the parentheses and put the x. Don't forget the minus symbol that we have in there. And then here we have to replace the value of h with +7. So here, again, be careful because we have an extra negative sign. That'll be a +7, which eventually will become just -7 because of minus next to a plus. And lastly, we have the value of k that's either adding or subtracting outside. So in this case, we have, we can put a plus, that's perfectly fine. And then the value of k will be over here, which is a -4. Okay. And after doing some simplification, because we have a minus next to a plus and a plus next to a minus for h and k, they simplify down to just having a minus symbol. So the final answer, I'm going to put it in black ink right here, will be this. So g of x is equal to 1 times parentheses x minus 7 to the power of 2 minus 4. This box right here says that this is the equation of a function in vertex form that reflects the changes that were described initially in the problem. Okay. Thank you for watching the video. I hope this helps, ladies and gentlemen, and I'll talk to you next time. Bye-bye.